declining to assist with the electrical project was a justified decision. Firstly, there is the matter of liability. Providing incorrect advice or direct assistance could lead to legal repercussions if damage or injuries result from the work. Secondly, safety is paramount. Electrical work inherently carries risks and should be handled only by qualified electricians. Involvement could potentially endanger yourself as well as the person receiving the assistance. Thirdly, professional ethics come into play. As someone associated with the electrical industry, there's a responsibility to uphold codes and standards. Supplying materials to individuals lacking the necessary qualifications can be seen as a breach of ethical conduct. Fourthly, payment concerns often arise when customers provide their own materials. The electricians typically warranty both the labor and the materials they use. Allowing customers to supply materials can complicate or even invalidate such warranties, leading to potential disputes. It is crucial to prioritize safety and professionalism. Instead of directly assisting, it is more appropriate to educate people about the importance of using licensed electricians and the inherent risks associated with do-it-yourself electrical projects. Suggesting a consultation with a licensed electrician allows for a professional assessment of needs and a proper quote for the necessary work. It's also important to remember some of the basic electrical principles involved in any electrical project. Before undertaking any electrical work, it's crucial to understand electrical circuits. A circuit provides a path for electrical current to flow. It includes a power source, conductors, and a load. A complete circuit is necessary for electricity to flow and power the load. Open circuits occur when the path is broken, stopping the flow of current. Short circuits occur when current bypasses the load, creating a low resistance path. This can cause excessive current flow, leading to overheating and potentially fires. Understanding voltage, current, and resistance is also key. Voltage is the electrical potential difference between 2 points, measured in volts. It's the force that drives the current through the circuit. Current is the flow of electrical charge, measured in amps. It's the rate at which electrons move through the conductor. Resistance is the opposition to the flow of current, measured in ohms. It limits the amount of current that flows in the circuit. Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage equals current multiplied by resistance. Voltage equals current times resistance. This law is fundamental to understanding and calculating electrical circuits. Series and parallel circuits are two basic ways to connect components in a circuit. In a series circuit, components are connected one after another, forming a single path for current flow. The current is the same through all components, but the voltage is divided among them. If one component fails, the entire circuit is broken. In a parallel circuit, components are connected side by side, providing multiple paths for current flow. The voltage is the same across all components, but the current is divided among them. If one component fails, the other components continue to function. Grounding is a critical safety measure in electrical systems. It provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and disconnecting the power. This helps to prevent electrical shock and fire hazards. Grounding systems typically include a grounding electrode, such as a ground rod or metal water pipe, connected to the service panel. Equipment grounding conductors connect the non-current carrying metal parts of electrical equipment to the grounding system. This ensures that if a fault occurs, the metal parts will not become energized. Circuit breakers and fuses are overcurrent protection devices that protect electrical circuits from damage due to excessive current flow. Circuit breakers are resettable switches that automatically trip and interrupt the circuit when the current exceeds a predetermined level. Fuses are one-time use devices that melt and break the circuit when the current exceeds a predetermined level. The size of the circuit breaker or fuse should be matched to the ampacity of the circuit conductors. Wiring methods and materials are essential for safe and reliable electrical installations. Conductors are typically made of copper or aluminum and are insulated to prevent electrical shock. The size of the conductor must be appropriate for the ampacity of the circuit. Cables consist of multiple conductors bundled together in a protective jacket. Common types of cables include non-metallic sheathed cable, armored cable, and underground feeder cable. Conduits are rigid or flexible tubes used to protect conductors from physical damage and moisture. Common types of conduits include rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Electrical boxes are used to enclose wiring connections and provide a safe mounting point for devices such as switches and receptacles. Boxes must be sized appropriately for the number of conductors and devices they contain. National Electrical Code or NEC is a widely adopted standard for safe electrical installations. It provides detailed requirements for wiring methods, materials, and equipment. The NEC is updated every 3 years to reflect changes in technology and best practices. Local electrical codes are often based on the NEC, but may include additional requirements specific to the jurisdiction. It is important to be familiar with the applicable codes before undertaking any electrical work. Electrical safety is paramount when working with electricity. Always disconnect the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Test circuits to ensure they are de-energized before working on them. Be aware of the potential hazards of electricity and take precautions to avoid electrical shock and arc flash. Working with electricity can be dangerous. If you are not qualified or comfortable performing electrical work, it is best to hire a licensed electrician. There are many resources available to help you learn more about electricity and electrical safety. These include textbooks, online courses, and training programs. If you're working with three-phase power, understand that it is a type of alternating current or AC electrical power where three conductors each carry an AC current of the same frequency and voltage relative to a common reference, but with a phase difference of 120 electrical degrees between them. Three-phase power is commonly used in industrial and commercial applications because it is more efficient than single-phase power. It can deliver more power with smaller conductors and equipment. Three-phase systems can be connected in two main configurations, Y and delta. In a Y connection, one end of each of the three windings is connected to a common neutral point. The voltage between any two-phase conductors is the line voltage, which is equal to the square root of 3, or approximately 1.732 times the phase voltage, that is the voltage between a phase conductor and the neutral. The current in each phase conductor is the line current. In a delta connection, the three windings are connected in a closed loop. The voltage between any two-phase conductors is the line voltage, which is equal to the phase voltage. The current in each phase conductor is the line current, which is equal to the square root of 3, or approximately 1.732 times the phase current. Three-phase power offers several advantages over single-phase power. Firstly, it provides more power for the same conductor size. Secondly, it produces a smoother, more constant power output, which is beneficial for motors and other equipment. Thirdly, it is more efficient to transmit and distribute over long distances. However, it also has some disadvantages. Firstly, it requires more complex wiring and equipment. Secondly, it can be more dangerous to work with due to the higher voltages and currents involved. Thirdly, it can generate harmonics, which can cause problems with sensitive electronic equipment. When working with three-phase power, it is important to take extra safety precautions. Always disconnect the power before working on any three-phase circuits. Use insulated tools and wear appropriate personal protective equipment. Be aware of the higher voltages and currents involved and take steps to prevent electrical shock and arc flash. Always consult with a qualified electrician when working with three-phase power. Understanding conductor ampacity is vital for safe electrical installations. Ampacity refers to the maximum amount of electrical current, in amps, a conductor can carry continuously without exceeding its temperature rating. This rating is influenced by several factors, including the conductor's material, size, insulation type, and the surrounding ambient temperature. Copper and aluminum are the most common conductor materials, with copper generally having a higher ampacity for a given size. Conductor size is typically expressed in American wire gauge or AWG. Larger gauge numbers indicate smaller conductors, and smaller gauge numbers indicate larger conductors. The ampacity of a conductor increases with its size. Insulation type also affects ampacity. Different insulation materials have different temperature ratings, which limit the amount of heat a conductor can withstand. Common insulation types include THHN, THWN, and XHHW. Ambient temperature refers to the temperature of the surrounding environment. Higher ambient temperatures reduce the ampacity of a conductor, as it has less ability to dissipate heat. The NEC provides tables that list the ampacities of various conductors based on their size, insulation type, and ambient temperature. For example, NEC Table 310.15b16 lists the allowable ampacities of insulated conductors rated up to 2000 volts based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. These tables must be used to determine the appropriate conductor size for a given application. Correction factors must be applied when the ambient temperature is higher than the values listed in the NEC tables. These factors reduce the allowable ampacity of the conductor to account for the higher temperature. Adjustment factors must also be applied when multiple current-carrying conductors are bundled together in a raceway or cable. These factors reduce the allowable ampacity of each conductor to account for the increased heat generated by the bundled conductors. When selecting conductors, it is important to consider the specific application and the applicable codes and standards. The conductor must be sized to carry the expected load current without exceeding its ampacity. Overcurrent protection devices, such as circuit breakers and fuses, must be sized to protect the conductors from overload. It is always best to consult with a qualified electrician when selecting conductors for an electrical installation. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and disconnecting the power. This helps to prevent electrical shock and fire hazards. Bonding connects the non-current carrying metal parts of electrical equipment to the grounding system. This ensures that if a fault occurs, the metal parts will not become energized. The grounding electrode system typically includes a ground rod, metal water pipe, or other approved grounding electrode. The grounding electrode conductor connects the grounding electrode to the service panel. Equipment grounding conductors connect the non-current carrying metal parts of electrical equipment to the grounding system. Bonding dampers are used to connect metal raceways, enclosures, and other metal parts to the grounding system. The size of the grounding and bonding conductors must be appropriate for the size of the service or circuit. The NEC provides tables that list the minimum size of grounding and bonding conductors. All electrical equipment must be properly grounded and bonded in accordance with the NEC and other applicable codes and standards. Improper grounding and bonding can create a serious electrical hazard. It is always best to consult with a qualified electrician to ensure that electrical systems are properly grounded and bonded. Always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements. Electrical codes and standards are continuously updated to reflect advancements in technology and safety practices. Familiarizing yourself with these codes is vital for ensuring electrical installations adhere to the latest safety regulations.